In this video, we're going to talk about dilutions. Now, to dilute something is typically what we learn to add water to something. So, for example, if I had sweet tea and it's too sweet for me, I add some extra unsweet tea and it will dilute it out. The same thing is true for us as chemistry teachers. When we buy acids and bases, sometimes they're going to be in units like this, 12 molar or 18 molar, and you've learned about molarity, and that is super strong. I don't even like using concentrations like that. If you spill that on you, it'll eat through your clothes very quickly. You spill it on your shoes, it'll eat through your shoes. There's nobody that needs it that concentrated. So how do you dilute something out into something that people can use, but it's still strong enough? Well, if you had a pool, you're going to take strong acid, and what you typically do is you put some of it in a bucket of water to dilute it, and then you pour it all around your pool and then turn your pool on to mix it all up. It's now diluted. Now, how much do you have and how diluted it is can be mathematically measured using the following formula. Molarity times volume equals molarity times volume. Now, a couple of things you need to know. Volume has to be in liters. Has to be in liters, and here's why. If I take the formula apart, molarity is really moles over liters, notice how that matches, equals moles over liters times liters. Simple math tells you that the liters cancel, and really when you're done with a dilution, all you have left is that goes away, and all you really have left, make a darker line, is you end up having the same moles on both sides. So you want to use the molarity times volume equals molarity times volume. It's really simple math. Let me give you an example. And I'm just going to do it as a word problem. A teacher needs 2.5 molar hydrochloric acid and 750 milliliters. If the bottle contains 12 molar, how many liters should she use? Now I'll give you a second to finish writing that down. If you need to pause it, don't let me get too far ahead of you, and we'll work the problem. Basically, here's what we're going to do. Molarity times volume equals molarity times volume. Whenever I set up a lab for my students, here's the deal. It tells me here that I've got 12 molar. That's the bottle that we buy from the company. And the question is, how many liters of that do I need? If I need 700, it says 750 milliliters. So I have to back that up 3 spots. So that's 0.750 liters. And I want it to be this concentration. Now you can already tell. The lab I'm giving that I tell my students we're going to do says it has to be 2.5 molar. Well, that's 12 molar. That's too concentrated. My question is, how much of this do I get and mix in water into that 750 milliliters so that everybody has that much? Well, it's all algebra skills. All I'm going to do is, if I want X, I'm going to get rid of that. So I'm going to divide by 12 molar. If I do that, molar goes away. The only thing that's not marked out is liters, so it's this times this divided by that when that disappears. So really what I'm going to do is I take my handy dandy calculator, 2.5 times 0.750 equals divided by 12. You'll notice I get that answer. 0.15625, and I'm going to write that down. 0.15625. Now what unit was that in? Well, it's going to be in liters, but I could convert it. And look, if I look at it real quick, if I move that 3 more decimals back to here, and this answer is right. Or if I'm going to do it for my students, I would move the decimal back 3 spots. If I went and got 156.3 milliliters of that really strong stuff, and I dumped it in 750 milliliters of water, everybody's going to have a safe amount. Move that so you can see it. So one more time. It took a little bit of that really strong stuff in a lot of water. When I mix it in that lot of water, it knocks it down so it's not so strong. That's what dilutions are. Let me give you another one real quick, and I bet you'll have it. The calculations here are very, very simple. Let's say that sulfuric acid, and I'm just going to write the numbers, is 18 molar, and I need 950 milliliters of it. Over here, let me move it here. I need 950 milliliters, and I need this to be 1.5 molar. How much of this am I going to pour out? Well, you can already see the math. You just read the word problem, plug the numbers where they go. You might even want to write something like that. This is the concentrated side. This is the dilute side. So I'm diluting it down. It's not as strong. How do I know the number's smaller? So I need a 1.5 molar, and I need a lot of that. But it's supposed to be in liters. So I'm back the decimal at 3 spots. Take off the milli. There you go. And there is my unknown. So I'm going to divide by 18 molar. And the m goes away, and so it's this times divide, and that tells me how much of this I need to pour out of this really concentrated bottle mixed with 950 milliliters, and everybody will have that much. So in this case, I'm going to take my same calculator, 1.5 times 0.950 equals divided by 18. My answer is that, 0.079. 1 repeating 6s and a 7. Now, if I move my decimal to the right 3 places, 1, 2, 3, isn't that 79.2? 79.2 milliliters. Now, why did I keep going to milliliters? You said that it had to be in liters, and that's right, to do the math. But I don't have things that measure liters very good, but a graduated cylinder uses milliliters. So I can move it 3 places to the right, and that'll give me a better number to use on my actual piece of equipment. But that's what I would do. I'm going to take 79.2 milliliters of that really strong stuff, dump it into 950 milliliters, and I'll end up having everybody with this concentration, and we're ready to do the lab. Dilutions is a very simple mathematics. You have a concentrated side and you have a dilute side. You plug your numbers in and solve.